Hello everyone, my name is Harsh Gandhi. I'm a PhD student in civil engineering at University of Massachusetts Lowell. I started working on project C3.7 from September 2020. Today, in this poster, I will talk about depth of fixity point of HP pile in integrated abutment bridges where depth of fixity is when deflection in pile becomes zero. States and municipalities have successfully used integrated abutment bridges as an effective means of eliminating breach joints, in which pile have fixed connection with abutment wall. Pile will observe lateral load due to the thermal expansion. Hence, in this study, pile was loaded with 0.15 inch of displacement and 30 kips of axial force. The main objective of this study is to analyze fixity point of HP pile affected with pile orientation, whether weak axis versus strong axis parallel to the center line of bearing, grade profile, whether slope ground or a flat ground, and a soil profile by varying the depth of medium sand, dense sand, and a strong rock. For the soil profile, three cases were considered. In case 1, depth of medium sand was 0 to 15 feet, depth of dense sand was 15 to 30 feet, and depth of strong rock was 30 to 45 feet. Similarly, in case 2 and 3, depth of medium sand varied from 0 to 10 feet and 0 to 30 feet, which increased density of soil layer surrounding pile in case 2 than case 3. In analysis, fixity point affected by the HP pile orientation. According to the hypothesis, soil behind abutment wall will apply more resistance. Thus, pile need more flexibility to achieve less depth of fixity point. Pile oriented in weak direction have greater flexibility in comparison with strong axis. Hence, in figure 6, we compared orientation of pile in strong axis versus weak axis of case 1. In a graph, line in a red color represent the strong axis and a line in a blue color represent the weak axis. As we can see through the graph, pile oriented have in weak axis have 2.1 feet of less depth of fixity in compared with the strong axis, and maximum moment in HP pile will also greatly reduce in a weak axis. As we can see here, it has a lower bending moment than a strong axis. Furthermore, for the analysis of fixity point affected by the ground grade condition, according to the hypothesis, ground slope with 10-degree angle will apply additional soil pressure than a flat ground. Hence, it will increase the depth of fixity in a ground slope than a flat ground. As we can see in figure 7, we compared the slope ground and a flat ground of case 3 of a weak axis. Line in red color represent the slope ground and the blue represent the flat ground. Slope ground condition pile is having 2.2 feet of increased depth of fixity than a flat ground. However, it slightly reduces the maximum moment of piles in a slope ground. In analysis of fixity point affected by soil profile by varying the density of soil layer surrounding the pipe. According to the hypothesis, denser soil layer will have more stiffness in a soil than a softer soil layers, meaning increasing the density of soil surrounding pile will decrease the depth of fixity of pile due to more stiffness of soil. In figure in figure 8, we compared case 2 and case 3, where case 2 is having denser soil profile than case 3. We can observe that pile with soil shallow layer of medium sand is having 3.2 feet of more depth of fixity than pile with the deeper soil layer of dense sand. Soil profile has no significant effect on moments of pile. To conclude, for all three cases, if the HP pile is oriented in weak axis, the length of fixity point and the maximum moment in HP pile will decrease due to the greater flexibility of pile in comparison with the strong axis. For all three cases, increasing the ground slope will increase the length of fixity point due to the additional soil pressure, but will decrease the maximum moment in a pile. And for all three cases, increasing the density of soil surrounding the pile will decrease the length of fixity. That's all from my side. If you have any question, I can answer that. Thank you.